Hello. In this video, we're going to start with the graph of y equals x squared, and using progressions, graph the relationship y equals 1/4 x plus 3 squared minus 5. Now when we talk about using a progression, we're actually applying what are called transformations. And though we're starting with quadratics, this idea of transformation applies to a large number of relationships that are out there. But before we actually do this detailed graph, we're going to do a quick sketch. And I would say that a quick sketch is a far more useful tool, because a quick sketch gives you a general idea of what the relationship looks like, and through that you can then figure out all sorts of interesting things. So the quadratic in this case is in what's called vertex form, and the general form of vertex form is written here. It's y equals a x minus k squared plus h. The reason we call it vertex form is because we can very easily read the vertex off of it, and that's at kh. So if we take a look here at our actual relationship, we can see the vertex is -3, -5. We always want to identify if it has a maximum or a minimum. Since this quadratic opens up, and we know that since a is positive, it opens up, it has a minimum value at -3, -5. So the maximum or minimum always occurs at the vertex. The axis of symmetry is the line that we draw that this shape is symmetrical across, and be sure you always write this as the equation of a line, and that's going to be x equals -3. The x value of the vertex is always the axis of symmetry. And the y-intercept can be quickly calculated by substituting x equals 0, so we sub x equals 0, and ideally we want to do a little practice with our either mental math or calculator work and do this in one step. And we see the y-intercept is at 0, -2.75. So what I'm going to do is use this information just to draw a quick sketch. And a quick sketch contains some key points to help us get an idea of what this shape looks like. And in the case of a quadratic, we want to include the vertex, we want to include the y-intercept, and if they're easy to calculate, the x-intercept. So with a quick sketch, we don't put a scale on it, we just kind of approximate. And when we approximate like this, it's important we actually write these points in. So we see the vertex is at -3, -5. We know that the y-intercept is 0, -2.75, I believe. There we go. And then I just kind of sketch in this shape. And we always like to dot in the axis of symmetry. There it is. So this tells me a couple interesting pieces of information. One, we have two real roots, or we have two x-intercepts. It tells me that one of the x-intercepts should be positive, so I can catch a possible mathematical mistake, which is known to happen. And if I wanted to, I could actually include some other points on here, and let's use a symmetrical argument. So if we travel 3 across to 0, -2.75, we can travel 3 in the other direction to get -6. -6, -2.75. So again, like I said, in a sketch, typically it's nice to have the x-intercepts, but in this, we're not going to actually calculate these right now. Okay, so now let's go and actually graph this using transformations. So to graph using transformations, the first thing we have to do is identify those transformations. And you can read your transformations off a quadratic by going left to right. And the key thing is always remember you apply shifts last. So often I'll do this in a two-step process. The first step is to apply the reflections and stretches, and the second step is to apply the shifts. When we talk about the transformations, we want to think about them in two ways. We want to think about what we do in words and what we do mathematically. So the a value represents our vertical stretch. So we have a vertical stretch by 1/4. And what that means is we take all the y values and we multiply them by 1/4. Pretty straightforward. The horizontal and vertical shift can be read from the k and h value. So we have a shift to the left, 3. And remember, the horizontal shift lies, so if it's plus 3, we're actually going to the left, and we have a shift down 5. So I'm going to take all the x values and I'm going to subtract 3 from them. So let's say x minus 3. I'm going to take all the y values and I'm going to subtract 5 from them. So notice, I've stated in words what I'm doing to each point, and I'm stating mathematically what I'll do to each point. So words, vertical stretch by 1/4. Mathematics, I multiply the y's by 1/4. Words, left by 3, down by 5. Mathematics, we're going to take each x value, subtract 3, each y value, and subtract 5. So when you graph using transformations, you always have to start from the parent graph. So we like to include that. So we have 0, 0, 1, 1, 2, 4, 3, 9. There's one side. And again, I'll say this again. These idea of transformations don't just apply to quadratics, they apply to a variety of relationships. And as long as you know the starting graph and you can identify the transformations, you can get the end result. So what I'm going to do is I'm going to take some points from one branch and I'm going to apply the transformations to those and then use symmetry to find the other part. So I'm going to write down a couple points here. 0, 0, 1, 1, 2, 4, 3, 9. And even though I don't have other points in the graph, I'm going to actually include a couple other ones. 4, 16, 5, 25, 6, 36. The reason why I'll do this is because just in case if the change in shape will draw some of those other points when they translate onto the graph. So the first step is I'm going to apply my vertical stretch. So I'm going to take each of these and multiply the y value by 1/4. So 0, 0 stays at 0, 0. 1, 1 becomes 1, 1/4. 2, 4 becomes 2, 1. 3, 9 becomes 3 and 9 over 4. 4, 16 becomes 4, 4. 5, 25 becomes 5, 25 over 4. And 6, 36 becomes 6, 9. Now what you might notice is that some of these numbers are very easy to graph, while other ones are going to be a bit of approximation. So I'm only going to pick the ones that are easy, and those are the ones I'm going to plot. I'll use the other numbers to kind of guide my hand as I sketch in the shape. So 0, 0, 2, 1, 4, 4, 6, 9, and there's that branch here, just like that. And now let's use that wonderful property of symmetry. We travel 2 over, so we go 2 and then 2 back this way. Travel 4, 4. And we traveled 6 to the axis of symmetry and 6 across. So there's my other branch. So this blue graph is the result of applying just the vertical stretch. So now what I'm going to do is I will apply the shifts. So 0, 0 is going to, if I subtract 3 from x and subtract 5 from y, so that will become -3, -5, and you'll notice that's my vertex. And now I'm only going to apply this transformations to the ones that are nice. So 2, 1 is going to, if I take 2 and I subtract 3, that's going to become -1. 1 and subtract 5, that will become -4. 4, 4, if I subtract 3, it will become 1. Subtract 5, it will become -1. 6, 9, if I subtract 3, it will become 3. And if I subtract 5, it will become 4. So again, what I've done is I've only picked the numbers that I can easily apply the math to and apply the transformation. So we have 3, -5, 3, -5. I have -1, -4. Pardon me. I have 1, -1. I have 3, 4. And I can connect these, but what I notice is that there's probably some points going on up here. So a couple of things I could do. I could take some other points and apply the transformation, or I could simply test a value. don't forget, when you're doing a graph, you can test these values. So let's test, say, since I seem to be doing every second value, let's test x equals 5. So y, if x is equal to 5, we get 1/4 5 plus 3 squared minus 5. So 5 plus 3 is going to be 8. 8 squared is 64. Divided by 4 is 16. 16 minus 5 is 11. Again, you can get your calculator out and do that in one step. So we have 5, 11, and that takes me just to a nice spot on the graph. So let's dot in my axis of symmetry. There's our axis of symmetry. I travel 2 across, 2 across. 1, 2, 1, 2. There we go. Oh, pardon me. I travel 1, 2, 3, 4. So we travel 1, 2, 3, 4. Let's try to get 1, 2, 3, 4. That's better. I travel 3, 6. And so I'm going to travel 6 across. 6, 7, 8. And that's going to take me right to the edge. So notice, oh, pardon me again. There's my result. So the gray graph is the final graph that we get if we apply this process of transformations. So now I can really quickly look at my sketch and say, okay, why do I feel good about this? Well, look at that, my y-intercept is about right. Based on my sketch, my x-intercepts seem to be reasonable, right? Because if we have the point -6, -2.75, well, that seems about reasonable where we're at. So this sketch gave me an idea of what this final transformation looks like. Another little thing I like to highlight is the idea of when you apply your transformations, pick values that work nicely for you. And that's going to come with practice. And finally, don't be afraid to test some values in the end just to fill in that graph. So again, these idea of progressions or transformations are very important because they'll help you get an appreciation of the shape of a wide variety of graphs that are used in all sorts of applications. However, in the grand scheme of things, what we really want to make sure we develop is a really firm understanding of how to make a quick sketch and to highlight the really critical values, those important points such as the vertex, x-intercepts, y-intercepts. Because if you can get an idea of the shape of a graph, you can then see how it applies to a wide variety of applications. I hope this video helped.